Hi friends, in this video we are going to discuss about the construction of transformer. So actually this is the diagram of a transformer. First we are going to discuss about the diagram of a transformer, and after that we are going to discuss about the each and every part. Okay, now see, so we know that this is the transformer. Just see here, first one is the secondary terminal. Okay, it means what? So this particular part representing the secondary terminal, and here this one, this is the primary terminal. Okay, so this is primary terminal and this one is a secondary terminal. And coming to another thing, that is explosion vent. Next one, transformer core. So this is the transformer core. Next one is transformer windings. So these are the transformer windings. Next, coming to another part, that is cooling tube. So here we have right side we have two cooling tubes, and left side we have two cooling tubes. The next part is transformer tank. So this complete box representing the transformer tank, and the yellow color representing the transformer oil. It means what? So in this particular transformer diagram, we have, first thing is we have the transformer tank, and in that transformer tank we are placing the insulating oil. We can also call it as transformer oil. And inside of this box we are placing the shell type construction of the transformer core, and we are placing on each limb we are placing the transformer winding, and from each winding we have taken the terminals. And coming to, in the right side we have cooling tubes, and in the left side also we have two cooling tubes. And coming to another most important part, that is Buckard's relay. So this is the Buckard's relay, and after that we have one conservator tank. And the last thing is breather. So these are the most important parts in a transformer, and with the help of operation of all these parts, there is a successful stepping up and stepping down the voltage levels by using this particular construction of a transformer. Okay, now we are going to discuss about each and every part. Then you know that what is happening in the transformer to convert or to step up and to step down the voltage levels with the help of this transformer. Okay, now first thing is coming to the first part, that is, so before we are going to explain about the individual parts, first we are going to discuss about some most important key points, and after that we are going to enter into the individual parts. Okay, now first thing is transformers are used to transfer electrical energy from one circuit to the another circuit through the electromagnetic induction. Okay, the point number 2 is they are used either to step up or step down the voltage levels. And point number 3 is a transformer is made of several different parts that function in their own different ways to enhance the overall functioning of a transformer. Okay, so another important points are, so this particular transformer include the parts, those are core, windings, insulating materials, transformer oil, tap changer, conservator, breather, cooling tubes, Buckard's relay, and explosion vent. So whatever the parts we discuss, so all the parts are we are mentioning here. And after that, the most important thing is here the core, windings, insulating materials, transformer oil, all these parts are almost available in every transformer. But coming to the some other parts, so the other components are available when the transformer having more than 50 kVA rating. Okay, so here core, windings, insulating materials, transformer oil. So all these parts are available in each and every transformer. But whatever the remaining parts are there or components are there, so those remaining components are always available when the transformer having more than 50 kVA rating. Okay, so this is very important point. Now we are going to enter into the individual part of a transformer construction. Okay, so from that, first we are going to discuss about the core. Okay, now the core of a transformer is used to support the windings, and it is made of soft iron to reduce eddy current loss and also hysteresis loss, and it will also provide the low reluctance path for the flow of magnetic flux. And the diameter of a transformer's core is directly proportional to the copper loss and inversely proportional to the iron loss. So this is about the part of a core. Okay, now point number 2, that is what? First thing is what? Core, and the second part is windings. Now coming to the topic of winding, so windings consisting of several copper coil turns bundled together, and each bundle connected to form a complete winding. And windings can be based either on input output supply or on the voltage range. And the windings that are based on the supply are classified into primary and secondary windings. The meaning of the windings to which the input and output voltage is applied respectively. On the other hand, windings based on the voltage range can be classified into high voltage and low voltage. Okay, so this is about the windings, because with the help of windings only we are going to stepping up the voltage levels and stepping down the voltage levels. For example, the number of turns in the primary or for example N1, the number of turns in the secondary are N2. Then the number of turns in the primary are greater than secondary turns, then this type of transformer we are calling as step down transformer. And for example, N1 is less than N2, then that type of transformer we are calling as step up transformer. So that depending upon the winding we are going to classifying the transformer, the type of transformer also. And the most important thing is when the number of turns are more, then that particular winding having high voltage. It means what? For example, number of turns in the primary, for example, number of turns in the primary are 10 turns and the number of turns in the secondary are for example 100 turns. Then the voltage in the secondary is high and the voltage in the primary is low. So that we are calling as this 100 turns winding we are calling as high voltage winding, and this one is called as low voltage winding. Okay, so this is about the windings. Now coming to the insulating materials. The insulating materials. Now see, coming to the insulating materials. So insulating materials like papers, cardboards are used to isolate primary and secondary windings from each other as well as the transformer core. The concept of insulating material is always insulating the primary winding and the secondary winding separately, including with the insulation of transformer core also, because all are combined means we are going to face some short circuits. So in order to avoid that particular problem, we are going to insulating each and every winding separately, including with the transformer core. And the next thing is these windings are made of copper due to high conductivity and ductility. And high conductivity minimizes the amount of copper needed and minimize losses. Moreover, high ductility results in easy bending of conductors into tight winding around the core, that also minimizes the amount of copper and the volume of winding. Okay, this is about the insulating materials. And the next topic is, that is, next part is transformer oil. Now coming to the transformer oil, this is very, very important part, because with the help of this transformer oil only, the heat will reduce. Now here, the transformer oil. The transformer oil insulates as well as cools the core and also coil assembly. The core and windings of a transformer must be completely immersed in the oil that normally contains the hydrocarbon mineral oils. So with the help of this transformer oil, the heat is produced in the windings as well as core. So that particular heat will be reduced due to this transformer oil. Now coming to another thing, that is conservator. Now the conservator is an airlight metallic cylindrical drum fitted above the transformer that conserves the transformer oil. It is vented at the top and it is filled only half the oil to allow expansion and contraction during the temperature variations. However, the main tank of the transformer with which the conservator is connected is completely filled with the oil through a pipeline. Okay, it means what? For example, this is the conservator. Initially, we are filling only 50%, because whenever the oil is expanded inside of the transformer, the quantity of this particular oil is increases. So due to that only, we can observe that something is happening in the transformer. So with the help of this conservator, we can easily analyze the running condition of a transformer. Okay, so that is the reason why conservator is an airtight metallic cylindrical drum fitted with the transformer, fitted above the transformer that conserves the transformer oil. It is vented at the top and filled only half with the oil to allow the expansion and contraction during the temperature variations. However, the main tank of the transformer with which the conservator is connected is completely filled with the oil through a pipeline. Now the breather. Now coming to the breather. The breather is a cylindrical container filled with the silica gel, which is used to keep the air that enters the tank moisture free. This is because the insulating oil, when reacts with the moisture, can affect the insulation, cause internal faults, which is why it is must to keep the air free from the moisture. In the breather, when the air passes through the silica gel, the moisture contents are absorbed by the silica crystals. So that is the reason why we are using the breather in the transformer. Now coming to the tap changer. To balance the voltage variations within the transformer, the tap changers are used. There are two types of tap changers. Those are on-load and off-load. In on-load tap changers, tapping can be changed without isolating the transformer from the supply, while in off-load, the transformer needs to disconnect it from the supply. So that is the reason why we are using the tap changer transformer. Mainly the top changer transformer is always, top changer is always used in the transformer, and the main purpose of this transformer tap changer is to balance the voltage variation within the transformer. Tap changers always used. Now coming to the cooling tubes. Now, as the name suggests, cooling tubes are used to cool the transformer oil. The circulation of oil within the transformer may be natural or forced. In the case of natural circulation, when the oil temperature rises, the hot oil naturally moves on the top and cold oil moves down, while in case of forced circulation, an eternal pump is used. So that is the reason why we are using cooling tubes in the transformer. Okay, the main purpose of these cooling tubes is cooling tubes are used to cool the transformer oil. But how this is happening means depending upon the points which we discussed here. And coming to the another most important thing, that is Buckhardt's relay. So here connecting pipe. placed over the connecting pipe that runs from the main tank to conservator tank. Buckhorst relay senses the faults occurring within the transformer. Okay, so here the Buckhorst relay senses the faults occurring within the transformer. It operates by gases emitted due to decomposition of transformer oil during the internal faults. This device is used to sense and protect the transformer from the internal faults. So the concept of Buckhorst relay is very very important in the transformer, and the Buckhorst relay senses the faults occurring within the transformer, and it is operates by the gases emitted due to the decomposition of transformer oil during internal faults. Now the next thing is explosion vent. So this is also most important part in the transformer. The boiling hot oil from the transformer is expelled during internal faults through the explosion vent to avoid explosion of transformer. This is generally placed above the level of the conservatory tank.